Hey everyone, and welcome back to the channel. Future coding stars, it's great to have you here. Today we're diving into another common and super important technical interview problem that you are guaranteed to see in some form during your journey. It's a fantastic way to test your foundational algorithm skills. We're going to tackle the find pair with given sum problem, specifically when working with a sorted array. While it sounds simple, there's a trick to solving this efficiently. And by efficiently, I mean solving it in a way that impresses interviewers and saves valuable processing time. Ready? Let's jump in. But before we get too deep, if you're serious about mastering creative code and algorithms for those dream tech jobs, make sure you hit that subscribe button and the notification bell. We're building a community of future coding stars right here. And hey, a quick like on this video really helps the channel out. Thanks. All right, let's define the problem exactly as you might see it in a technical interview. You are given a sorted array of integers and a target integer sum. Your task is to determine if there exists any pair of elements within that array that adds up to exactly the target sum. You just need to say yes, true, or no, false. You don't need to return the pair itself, just whether it exists. For example, if your sorted array is 1, 3, 5, 7, 8, 11, and your target sum is 12, what would you do? Well, you can see that 1 plus 11 equals 12. So in this case, the answer would be true. What about if the array is 2, 4, 6, 8, 10, and the target is 7? No matter which pair you try, none of them add up to 7. So for this example, the answer would be false. Simple enough problem statement, right? Now, this is the point where in a real technical interview, you'd be given a few minutes to think. And that's exactly what I want you to do right now. How would you approach this problem, keeping efficiency in mind? What are the different ways you could check every possible pair? Are there any shortcuts you can take because the array is sorted? Okay, hopefully you've had some thoughts. Maybe you came up with a clever approach. Let me know your creative solution in the comments below. I'd love to see how you tackled it. There are a few ways to solve this, but one of the most elegant and efficient solutions for this specific problem leverages a powerful technique called the two-pointer technique. This technique is an absolute must-know for coding interviews. It's used in many different problems, often related to sorted arrays or linked lists. Now, in future videos in this series, we're going to dive deep into the why and the mechanics of the two-pointer technique, understanding precisely how and why it works so efficiently. But for this problem, let's focus on how we can apply it to find our pair sum. The core idea here is surprisingly simple. We'll use two pointers. Let's call them left and right. We initialize left at the very beginning of the array, index 0, and right at the very end of the array, the last index. Then we enter a loop that continues as long as our left pointer is still to the left of our right pointer. Inside the loop, we calculate the sum of the elements that our left and right pointers are currently pointing at. We then compare this sum to our target sum. If the current sum is exactly equal to the target sum, we've found a pair. We can immediately say true and finish. If the current sum is less than the target sum, we need a larger sum. Since the array is sorted, the only way to potentially increase the sum using one of our current pointers is to move the left pointer one step to the right. Moving left to the right will include a larger number in our sum on the next iteration. We don't move the right pointer left because that would only decrease the sum further. If the current sum is greater than the target sum, we need a smaller sum. Similarly, because the array is sorted, the only way to potentially decrease the sum is to move the right pointer one step to the left. Moving right to the left will include a smaller number in our sum on the next iteration. We don't move the left pointer right, as that would increase the sum even more. We repeat this process, calculate the sum, compare to target, move either the left or right pointer based on the comparison. The loop continues until the left pointer crosses or meets the right pointer. If the loop finishes without finding a pair equal to the target sum, then no such pair exists, and we return false. Let's see how this looks in actual code. We'll use Python, a common language for interviews, and work in VSCode. Okay, let's break this down line by line. Here's our function definition, taking the sorted array R and the target sum as input. Good practice here with a docstring explaining what the function does. We initialize our left pointer variable to 0, the index of the first element, and our right pointer variable to the index of the last element, which is the length of the array minus 1. This while loop is the heart of our algorithm. It continues iterating as long as left is less than right. When they meet or cross, it means we've checked all possible unique pairs using this method. Inside the loop, we calculate the sum of the elements at the current left and right indices. We first check if current sum is exactly equal to target sum. If it is, we found our pair and we immediately return true. If the sum wasn't equal, we check if current sum is less than target sum. If it's too small, as we discussed, we increment the left pointer by 1, moving it one step to the right to potentially include a larger value in the next sum. If the sum wasn't equal and wasn't less than, it must be greater than the target sum. In this case, we decrement the right pointer by 1, moving it one step to the left to potentially include a smaller value. If the while loop finishes without ever hitting return true, it means no pair summing to the target was found, so we return false after the loop. And here's just some example usage to test our function with the scenarios we discussed earlier. Let's run this. And there we go. True, false, false, true. Exactly as expected. The code implements the two-pointer logic effectively. You can download this code snippet and the examples directly from the link in the video description below. Practice running it yourself. Now, you might be thinking, okay, that looks like it works, but how do I know it checks all possible pairs efficiently? And why is this method so much better than checking every single combination? Great questions. The elegance of the two-pointer technique lies in how it systematically eliminates possibilities without needing to check every single pair. Because the array is sorted, the movement of the pointers guarantees that we are either getting closer to the target sum or confirming that a pair with the current elements and pointers cannot form the target sum with remaining elements. We'll dedicate a future video entirely to breaking down the mathematical intuition and the proof of correctness behind the two-pointer technique. Understanding the why will unlock your ability to apply this pattern to many other complex problems and write even more creative code. So stay tuned for that deep dive. This problem is just our first application of this powerful pattern. And there you have it, a solid, efficient solution to the pair sum problem in a sorted array using the two-pointer technique. A must-know for your next technical interview. Mastering fundamental problems like this is key to becoming a future coding star. If you found this video helpful, please give it a thumbs up. Don't forget to leave your own creative solutions or thoughts on this problem in the comments below. Share this video with anyone you know preparing for technical interviews. Remember to subscribe for more algorithm breakdowns, creative code tips, and technical interview prep. Keep practicing, keep learning, and I'll see you in the next video where we might just be diving deeper into the two-pointer magic. Happy coding!